Hello, welcome to course number MALR 2077, Psychopharmacology, Brain Structure and Development, and Severe Mental Illness. This is part 1 of a 2-part class. You are currently listening to part 1, week 1, lecture 1, Setting the Stage. My name is Dr. Julie Masesovic, and I will be taking this journey with you over the next 2 semesters. This first video will take about 45 minutes. This is by far the longest one, as I introduce myself and the class, and you can expect future videos to average around 20 to 30 minutes in length. In the first semester of this class, we will cover anatomy and physiology of the brain and focus on learning everything we need to know to prepare us for the second semester, which will focus more on psychopharmacology and severe mental illness. My objectives for the class are the following. First, I will introduce myself and tell you a little bit about where I'm coming from. Like any avenue of study, there are differing approaches to the field of neuropsychology, and mine is just one perspective. Next, I will review some of the logistics of the class and the expectation in terms of reading and assignments. All of this is mapped out in your syllabus, but I'll restate major points here. Just so you know up front, it's not my intention to teach during the didactic portions what you are already reading in the assigned reading. So for that reason, it's really important that you do both the reading and watch the PowerPoint presentations to gain the maximum amount of information from this class. Another objective I have for this class is to convince you of how cool neuroscience truly is, in case you're not already excited. I will present to you why, in my opinion, it is crucial for you as a professional in this field to be knowledgeable about neuropsychology. The bulk of the class today will be an abbreviated history of neuroscience. From ancient times to present, we've come leaps and bounds towards knowledge of the brain and nervous system and how it affects our moods and behaviors. We'll take just a quick look at the main points in history. For some of you, this may be a bit of a drag because it's a lot of information to hold. I get that. But I think it's important to put into context of history how humans have come to understand human consciousness and the connection between essentially the body and the mind, as we began to grapple with the role of the brain as it relates to physical and psychological health, as well as spirituality and philosophy of life in general. The rest of the semester will focus on what you need to know, the vocabulary, anatomy, nuts and bolts of using neuroscience in the field as a clinician. My hope is that this historical perspective will ground your knowledge base with a general understanding of how we got to where we are today in regards to understanding the brain, and also to hopefully stimulate a sense of awe and wonder about the brain, a topic of intense study and in the least, speculation and experimentation dating back to Neolithic times. Finally, to wake you up after our walk through memory lane, we'll do some myth busting on some common beliefs about the brain. These myths and their explanations come thanks to Professor Sam Wong, PhD, who is Associate Professor of Molecular Biology and Neuroscience at Princeton University. The first common belief we'll look at is that drinking alcohol kills neurons. A second is that playing classical music to your children either in utero or in early childhood will make them smarter. Finally, we'll explore the idea that we only use 10% of our brains. So if nothing else, after this lecture, you can wow your friends and family with some fabulous trivia. So let's start it. My name is Julie Masesovic. I'll be your instructor for both parts of this course. I'm a licensed psychologist and an alumna of ITP. I'm currently the program manager for a licensed children's group home in Redwood City, where we do crisis intervention, therapy, and residential treatment for runaway youth, youth at risk, and families in crisis. I'm also a clinical supervisor for pre-licensed doctorate level trainees. As a therapist, I've worked with a variety of populations. Mostly, I've worked with children and families in various settings. The approach I take is eclectic. As a graduate of ITP, I am trained as a transpersonal psychologist. I also specialize in somatic psychotherapy. My dissertation research was about therapeutic presence and the embodied transcendental experience of being present with a client. As a clinician and a clinical supervisor, I take a humanistic, existential, person-centered approach, drawing on somatics, neuropsychology, cognitive behavioral, attachment, and systems approaches, among others. I like to think I take the juiciest part of all modalities I encounter, and I blend them in with my own unique approach. I believe the therapeutic relationship is ultimately the key to successful therapy. More recently, my passion has centered around the interpersonal neurobiology approach of Dan Siegel and colleagues. This course is very much grounded in that approach. This is Dan Siegel. He's a renowned child psychiatrist and therapist, as well as clinical professor of psychiatry at the School of Medicine at the University of California, Los Angeles. Briefly, the interpersonal neurobiology perspective is a focus on how the brain develops in relationship. In the womb, we are in relationship to our mother. We evolve in relationship with others and prominent caregivers, and as our brain develops, it attunes to the persons closest to us. Now, if this is a healthy, enriching, attentive environment, our brains have the good fortune to evolve in a healthy, flexible, adaptive way. If the relationships are chaotic, inconsistent, abusive, neglectful, or unpredictable, our brain adapts to expect a world that is chaotic, inconsistent, abusive, neglectful, and unpredictable. In response to less than ideal environments, we develop coping skills and habits that help us survive. These survival skills, for example, hypervigilance, anxiety, and dissociation, to name a few, may then result in what we would define as mental illness if it interferes with our ability to function effectively in the world. The good news is that the brain continues to evolve throughout our lifetime. Every day and every moment is another opportunity to affect our brains and create healthier pathways that can lead to increased functionality, a deeper sense of contentment and joy in life, better relationships, etc. This is where we therapists can play a role. Just like our brains developed in relationship to our early caregivers, we can develop a relationship with clients that also deeply affects the development of the client's brain and most likely our own brain as well. I think this is one of the big benefits of being a therapist. In a sense, we are reparenting the brain. If we understand neuroscience and psychology, we can coach clients to manifest their brain potential. I find this really exciting, and I hope to pass on some of that passion to you this semester. So why bother learning neuropsychology? I propose several reasons why you should become knowledgeable in this area. Number one is simply to keep up with the field. The field of psychology seems to have these flavors of the month. Even in the span of my relatively short career in psychology, the zeitgeist has evolved from a focus on classical behaviorism during my undergraduate studies, which then morphed into more of a CBT approach. More recently, we seem to be becoming more holistic in how we conceptualize mental health. Attachment theories and systems theories have become more acceptable, and now more than ever we see the transpersonal, whatever words people use to describe it, becoming a prominent theory. For example, mindfulness is incorporated in more and more modalities. People are beginning to understand that you cannot treat the mind alone and expect optimal health. We must consider the body and the spirit. Without a basic understanding of the brain, you cannot claim to fully understand a holistic approach to psychological health. Some believe that in time, psychiatry will be essentially replaced by neurology as we begin to find the neurological basis for all behaviors and mental illnesses. Whether or not you will entirely buy into this reductionistic approach, you may want to be able at least to understand it and be able to formulate a response based on historical facts and research. Ultimately, no matter what your paradigm is or will become, we cannot deny that when you get right down to it, we are altering brain structure. This flavor is not going away and is only going to grow as we learn more and our technologies develop. You'll see in today's review of the history of neuroscience how far we have come in a short period of time, and we can only imagine how far we may yet go in the span of your career in this field. Number two, and more practically, knowledge of neuropsych adds to your tool belt a set of skills that will enhance your clinical intervention with clients. Here's an example. A client comes to you. She is a survivor of domestic violence. She struggles daily to follow the guidelines of the restraining order that she put into place because 90% of her whole being wants to go back to her abusive ex-partner. She explains to you that it feels like an addiction with constant cravings that threaten to hijack her common sense and send her running back into the violent relationship she knows objectively is so destructive to herself. One intervention might include explaining how the brain works with addictive behavior, describing how the neural pathways are formed and cemented in after repetition of behavior, and then habits are formed. The process of recovery involves forming new patterns and new neural pathways that will diminish the influence of the old. This approach can have the effect of separating the client from the shame and guilt associated with wanting to return to the abusive partner. It normalizes her brain proclivity and provides a tangible explanation for why it is so hard to break the patterns, thus setting the stage for recovery. Speaking of addiction, in a more traditional sense, being a competent therapist will involve understanding and helping your clients to understand the mechanisms of addictions to drugs, such as cocaine, alcohol, and methamphetamine. You'll be able to illustrate for your clients how these substances work to create that much desired high and then potentially the destructive and addictive consequences that can follow. If you want to work with people who are struggling with substance abuse, in my opinion, you need to understand the interaction of drugs and the brain. And these days, most people are struggling with addiction in one form or another, be it caffeine, work, sex, or whatever. Similarly, and even more broadly, neuropsychology will help you to understand and work with clients with a variety of diagnoses: ADHD, autism spectrum disorders, memory problems, depression and anxiety, schizophrenia, and other forms of psychotic disorders. The list goes on and on. Nowadays, in our fast-paced society, we tend to want quick fixes. An MD is seen more than willing to oblige, so many of the clients you will see are going to be on one or more medications. I think it is your ethical obligation to consult with your client's other providers and develop a collaborative and therefore more efficacious treatment plan. Understanding neuropsych helps you to consult with doctors, psychiatrists, and pharmacists, and be able to communicate in a knowledgeable way about psychopharmacology. Lastly, I encourage you to ponder where we are headed as a species. We regularly self-medicate with caffeine, medical marijuana, and alcohol, as well as fast-paced stimulating experiences such as video games and television. If we feel depressed, there's a drug for that. If we're not able to sleep, be attentive in school, or even have sex effectively, there's a pill for that. Are we as a species going to become dependent on outside agents to manage our dysfunction, or will we evolve to a place whereby we are managing our stress, nurturing our minds, bodies, and spirits effectively, and have a certain mastery over our lives, such that a majority of illnesses, both mental and physical, can become obsolete? Psychoneuroimmunology teaches us that many of our diseases are a result of our stressful environments, which overwhelm an organism not designed to digest such high levels of ongoing stress. The diathesis stress model suggests that while we may have a predisposition genetically for an illness, it is the environment that triggers expression of that illness. It is an environment of constant stress, exposure to increasing levels of toxins, and unhealthy bodies that allow disease, physical, mental, and spiritual, to manifest. Knowledge of neuropsychology and psychoneuroimmunology allows us to envision and actively create a world that is holistically a healthier place. Naturalist and poet Diane Ackerman put it succinctly when she wrote in her 2004 An Alchemy of Mind the following: "Synaptic transmission underlies everything the brain does, all our knowledge, motives, whims, and desires." She goes on to quote the 2002 book The Dana Guide to Brain Health, which said, ultimately, all that we are, all our memories, hopes, and feelings can be boiled down to the banal transfer of a few ions across the membrane wall of cells. Now let's briefly talk about some logistics. This, of course, is an online course over the span of 9 weeks. There will be 5 lectures like this one posted on Angel on the first day of weeks 3, 5, 7, and 9. You are expected to watch these videos in addition to completing weekly assignments. As I stated before, I will not be repeating the material you are learning in the reading, although all will relate to what you are reading. I will try to fill in the gaps of the reading during the 5 short didactic portions. There are 3 required books for this course. As you can see on the syllabus, I've broken the reading down into what I think are reasonable parts that will allow us to finish the books by the end of the semester. The Cossolino and Armstrong books will be read in their entirety, while the coloring book we will only do parts of. So in addition to the reading assignments, there are some tangible assignments I will ask for that will help me to discern that you are actually digesting and thinking about the material. I know that there's a lot of potentially new vocabulary in anatomy. It's a lot of information to learn in a short period of time. I do not expect you to memorize all of it, and there will be no test in the end. However, I do want you to engage different parts of your brain to maximize the potential that the information might stick. So I've created assignments that require some amount of integration of both. Reading and coloring the plates in Diamond and Schabel's coloring book will hopefully help you to integrate the anatomy of the brain by using not only the intellectual portions of your brain, but also engaging the creative artistic parts. I don't need you to send me all of the plates that you color, but I would like for you to scan or photograph at least one of your drawings each time that there are coloring assignments. My hope is that you will find the actual coloring of the plates will help you to integrate the material. I also encourage you to search online for videos such as the 2 examples I added to the first week of the syllabus to get a more interactive and visual experience of some of these hard to grasp on paper things. The terms and concepts assignments are designed to help you put into your own words the concepts of the reading. Please provide just a few sentences illustrating for me that you understand the meaning and relevance of these terms, and then submit your document into the appropriate folder in Angel by the due date listed. This will both help hold you accountable to the reading and allow me to see that you're understanding the material. If it helps to write briefly about your particular knowledge of or relationship to the concept, I would prefer your personal connection to the concepts rather than just a rephrasing of the book's words. I'd like you to really be able to have a clear understanding of these terms. In addition, because this is an online course and we can't be together in a classroom to have a discussion, there will be an online discussion forum each week. I may pose a question or leave it open to your questions and comments. The expectation is that you're engaged in a class discussion on a weekly basis and in some way relating the material to your experiences and clients. Post your questions and ideas as they relate to the reading material or related topics. This experience will not only enrich your learning experience, but it's a portion of your grade. Please refer to the syllabus for more concrete expectations. There will be a final paper. The paper is expected to be 4 to 6 pages in length, with at least 2 references other than your assigned text. So keep in mind as you progress through the reading and the class discussion if any particular topics strike you or fill your soul with passion or fear, or just an urge to know more about it. I'm working on a bibliography of books I have found along the way and have enriched my learning on the topic. You might find one of those of particular interest. I will look to post that bibliography by the middle of the semester, so you can peruse it if you find that helpful. On week 7, I'll ask you to turn in a paragraph that describes the topic that you're considering for your final paper. In terms of contacting me, there's many ways to do so. Refer to your syllabus for specific contact information, because I'd rather not post this on the World Wide Web. And just a word about collaboration. It is my hope that this class will be a collaborative process. I encourage everyone to share any resources you find, ideas that come up, and provide any feedback to me or the class in terms of how this experience is for you and how you could better be learning or integrating the materials. I am by no means the world's leading expert on neuropsychology, and I continue to learn and grow on a daily basis. I will not have the answers to every question, but I will try my best to explore any and all inquiries with you and maybe give some leads as to where to research different topics of interest to you. I'm really excited to be learning with you. So let's move on to a very abbreviated history of neuropsychology. Evidence of what has been interpreted as a primitive form of brain surgery dates our knowledge of the brain as far back as 5000 BC. In 1865, a first skull with said evidence was discovered in what is thought to be an ancient Inca burial ground. Thousands of similar skulls have since been discovered, some dated as old as 10,000 years. The skulls have holes drilled or scraped into them, but also indication that the person survived the surgical procedure for years after the fact. These are thought to be the result of a practice now known as trepanation. Actually, modern anthropologists have discovered tribes that were drilling holes in the skull as recent as the 1990s. Trepanation is thought to have been used to cure headaches, seizures, combat wounds, and to treat so-called mental disorders in various cultures throughout the world. The question remains whether the trepanation was done for the actual head injuries or to release so-called evil spirits, as headaches were commonly attributed to spirits. Interestingly, when that skull was discovered in 1865, a prominent physician at the time, Paul Broca, was consulted. Pierre-Paul Broca was a French physician, surgeon, anatomist, and anthropologist. Broca reportedly wrote more about trepanation than what he eventually became famous for, which is discovering the localized language center for speech in the brain, now known as Broca's area. His work revealed that the brains of patients suffering from aphasia, or language disorders involving disturbances in the formation and comprehension of language, contained lesions in a particular part of the cortex in the left frontal region. This was the first anatomical proof of the localization of brain function, but we'll get back to that later. The earliest known written reference to the brain has been identified as the Edwin Smith Surgical Papyrus, supposed to have been written around 3000 BC. Discovered in 1860, but not translated until 1930, this 15-foot papyrus scroll, known by some as the Secret Book of the Physician, is a copy of Egyptian records. The author was reportedly a physician who noted anatomy of the brain and describes 27 cases of brain injury. The word for brain, as it appears in the scroll in hieroglyphics, is seen at the bottom of this slide. Among other things, the author of the scroll recognized that damage to the brain can paralyze limbs in opposite sides of the body and cause problems in hand-eye coordination. The author also noted that a blow to one side of the brain can cause damage to the other side of the brain. There was also advice about how to treat various head injuries. The back side of the scroll described medicines and spells used. Ancient Egyptians reportedly did not utilize trepanation, or at least very few skulls have been found to indicate that they did. Egyptians are thought to have known that the brain was involved in bodily function, notably to produce mucus for the nose, but they were wary of creating opportunities for evil spirits to enter the body through holes in the head. Egyptians reportedly believed that the heart was the source of good and evil. They considered the brain a relatively unimportant organ, and in fact removed the brain and disposed of it in preparation for mummification, while preserving the heart. The brain was suggested by some to be viewed essentially as cranial stuff. Most of our modern concepts about philosophy and science originated with the ancient Greeks. Our knowledge of 600 to 500 BC suggests that ancient Greeks had differing views of the function of the brain. It's thought that the Pythagorean philosopher Alcmaeon was the first to suggest that the brain was where the mind was located, but that debate was long fought. Between 400 and 300 BC, the view that the heart was the source of consciousness persisted. Humorism was the common theory of the times that the human body is filled with four basic substances called the four humors, which are held in balance when a person is healthy. It is closely related to the ancient theory of the four elements and states that all diseases and disabilities result from an excess or deficit in black bile, yellow bile, phlegm, and blood. Hippocrates, the ancient Greek medical doctor now known as the father of medicine, is credited for this theory dating around 400 BC. It's important because he was reportedly the first to argue that diseases had natural causes in a time where disease was thought to be the whim of the gods. This theory of the four humors influenced medical thinking for more than 2,000 years until finally discredited in the 1800s. Hippocrates may have been off with regard to his bile theory, but he is also credited as being the first to challenge the belief that the heart was the source of consciousness. Hippocrates correctly asserted that the brain was the center of control or the seat of intelligence, and also involved in sensation. Reportedly, it was his work with epilepsy that brought about a revolution regarding our knowledge of the brain. Documentation indicates that at one point he described epilepsy as a disorder of the brain as opposed to a curse from the gods, as was the common belief at the time. He believed that epilepsy was a result of humidity in the brain, or rather too much phlegm, which resulted in corrosion of the brain. Now, Plato also speculated that the brain controls intelligence and is the divinest part of us. Interestingly, though, Plato's student, Aristotle, on the other hand, is said to have thought the heart was the seat of intelligence and the brain was merely a cooling system for the blood. Based on biology and his dissections of animals, Aristotle thought the heart must control the body because it moved, it was centrally located, and it is the first to develop in the embryo. Human dissections began in Alexandria, Egypt, where condemned criminals were actually dissected while still alive in some cases. Dissection of the human body allowed biologists to identify anatomical structures within the brain. In 170 BC, during the Roman Empire, Greek anatomist, physician, and philosopher Galen dissected the brains of sheep, monkeys, dogs, pigs, and others. Galen was reportedly the earliest to show that the brain controlled action by making an incision in a pig's neck, thereby silencing the squealing, but not the thrashing movements of the body. Galen also observed that patients lost their mental faculties when they sustained damage to their brains. He made various conclusions about specific locations of the brain being associated to specific functions of the brain. He also argued that the brain ventricles produced animal spirits, which made thinking possible. Theories about the ventricles would become popular again later in history. I found little information in the 1st through 4th centuries, except that in the 4th century there was a growing knowledge that damage to different parts of the brain affected different functions. Fast forward to the Middle Ages, there's documentation that much was being done in the medieval Muslim world to contribute to neuroscience. For example, in the 8th century, Islamic scholars translated the works of Hippocrates and Galen into Arabic and added their own discoveries. A major hospital in Baghdad in 982 was reportedly directed by leading scholar Muhammad ibn al-Razi, who is credited with distinguishing measles from smallpox, but that is not the extent of his contributions. He also reportedly investigated psychosomatic conditions and wrote a 30-volume encyclopedia of medicine. Among other accomplishments, he described the symptoms of apoplexy, now known as stroke. Another Islamic scholar, Ibn Sina, known as the Prince of Physicians, reportedly wrote over 100 books, including a standard reference text called the Canon of Medicine, in which he describes tuberculosis and distinguished meningitis from other neurological conditions. During the Renaissance, our knowledge grew when brains were once again permitted to be dissected after 1,000 years of prohibition on autopsies. This change came about when the so-called Black Death, or plague, baffled scientists, and there was need to study the brain in research of a cause. Andrew Vesalius became known as the founder of modern human anatomy. He contributed to our knowledge by dissecting human cadavers and reportedly identifying many anatomical structures of the brain and proposing 7 pairs of brain nerves. We now know there are 12 pairs of cranial nerves emerging from our brain and 31 pairs of spinal nerves emerging from the spinal cord. Vesalius also asserted that the brain and soul were separate, which is an ongoing debate even today. Also during this time period, Leonardo da Vinci contributed to the field by doing detailed sketches of the brain anatomy of corpses. He also sculpted the brain in 3D, including the ventricles. He attributed mental faculties to the different ventricles, such as sensation, cognition, and memory. At one point, da Vinci demonstrated that a frog without a heart could briefly survive, but one with a severed spine could not, challenging the belief that the brain was less important than the heart. Also around this time, Rene Descartes was studying physiology of the brain. He, of course, is best known for his theory of dualism to tackle the quandary of the brain's relationship to the mind. He also suggested that the pineal gland was where the mind interacted with the body after studying the circulation of cerebrospinal fluid. He suggested the pineal gland was the soul's conduit to the body and responsible for the human passions. So now we can begin to see how we're going from a more philosophical approach to what makes us tick, to a more scientific one thanks to our ability to dissect and our advancing technologies. You can see the learning curve is starting to really take off. The first simple form of a microscope is dated as early as 1590 in the Netherlands, although the name microscope was not used until Galileo later developed the compound microscope in 1625. The microscope, of course, transformed how we were able to witness the microscopic workings of the brain and nervous system. Thomas Willis, a lucrative physician in Oxford and then London, is called the father of neuroscience because of his various contributions. It was Willis who coined the terms hemisphere and lobes. He took a physiological perspective and began to hypothesize about so-called higher and lower functions of the brain and also localization of function. He was reportedly particularly interested in looking at both the behaviors as well as the brains of people who suffered from manic disorders and hysteria. This is notable as one of the first times that psychiatry and neurology came together to study the individual. Through his in-depth study of the brain and behavior, Willis concluded that within the lower region of the brain, automated responses such as breathing, heartbeat, and other various motor activities were carried out. While some of Willis's work was later discovered to be false, Willis paved the way for further exploration in the area of neuropsychology. Interestingly, still bound by traditional belief systems, Willis's 1664 book entitled Anatomy of the Brain and Nerves still proposed that the brain was powered by animal spirits. A widespread interest in electricity in the 18th century perhaps inspired John Walsh to experiment with fish known to shock humans, as well as eels. His research reportedly suggested that electricity may have some role to play in the brain. Walsh reportedly consulted with electricity authority, Benjamin Franklin, who, as we know, was conducting extensive experiments with electricity at the time, including his famous flying of the kite with the key in 1752. In 1791, Luigi Galvani published his discovery of bioelectricity, demonstrating that electricity was responsible for sending nerve impulses to the muscles. He famously experimented with frogs. Benjamin Franklin reportedly experimented with using electricity to try and cure, at various times, paralysis, palsy, deafness, and finally, with some success, so-called hysteria. Franklin also proposed using electric shock to treat melancholia. In 1776, John Birch, reportedly in response to Franklin's proposal, is said to have successfully treated a man who was suffering with melancholia, as a result of the grief related to the death of his children. In 1796, German physician Franz Gall developed cranioscopy, now known as phrenology. Gall believed that the cortex of the brain was made up of specialized organs representing 27 different faculties with distinct forms. He produced a cerebral map and was able to diagnose patients based on putting his hands on their head to feel the shape of their head. This method was popular until about 1840. Despite its eventually being disproven, phrenology was influential in the 19th century psychiatry and modern neuroscience. Gall's assumption that character, thoughts, and emotions are located in the brain is considered an important historical advance towards neuropsychology. Some other significant dates: 1837, the first description of neurons. 1848 was the infamous case of Phineas Gage. Phineas Gage was the railroad worker who survived an iron rod piercing through his skull. The discovery that his personality changed significantly after this brain trauma began to raise the question about how the brain's frontal regions play a role in affect, behavior, and personality. In 1861, Broca is credited with identifying the specific location of speech in the brain, thereafter named Broca's area, while John H. Jackson concluded that the left hemisphere is responsible for language functions, while the right for emotion. Jackson, a neurologist, did lots of work with brain lesions and paralysis. Golgi in 1870 developed a staining technique that revealed the structure of individual sensory nerve cells. What followed were many experiments involving slicing of the brain for investigation under a microscope using these stains. Debate was ongoing regarding how the cells actually communicated with one another. Also, it was in 1881 when young neurologist Sigmund Freud completed his MD and began his medical career. More about Freud in a moment. But I just want to check in. I realize that I'm throwing a lot of historical data at you. I'm obviously leaving a lot out also. And I realize that this is not critical to your understanding of neuropsychology. Again, I just want you to get a basic frame of reference as to what got the ball rolling to where we are today. so hang in with me for just a little bit more. A little bit about Freud. Now, many of you know Freud for his psychoanalytic theories, but what I find interesting, but which is seldom discussed, is that a lot of his theories stem from his scientific and medical understanding of anatomy and neurology. Sigmund Freud studied medicine at the University of Vienna between 1873 and 1881, receiving his MD. He studied the sexual anatomy of eels and the physiology of the fish nervous system. He was also an early researcher in the field of cerebral palsy, which was then known as cerebral paralysis, publishing several medical papers on the topic. In 1883, Freud, age 29, won a fellowship to work with Jean-Martin Charcot, a renowned neurologist who was studying hypnosis in a hospital in Paris. In 1885, Freud spent some time at Vienna General Hospital studying with Theodor Meinert in a psychiatric clinic. Freud developed a staining technique called the gold chloride stain in an effort to isolate nerve cells. He was reportedly trying to test the theory that the embryo in the womb recapitulates the history of evolution. Freud's ideas were considered scandalous at the time because he was asserting that we contain within us the biological history of our primitive ancestors, thus explaining instinctual drives such as sexuality, rage, and envy. His theory of the ego, id, and superego identifies the id as being the premature, uncivilized part of ourselves that Freud proposed we share with our reptilian and mammalian ancestors. These theories were frowned upon at the time. In fact, Freud wrote his book, The Project for a Scientific Psychology, where he postulated that conscious and unconscious behavior is organized and stored in the brain. But despite his passion for this theory, Freud seemed to understand that his thinking was ahead of his time, and the book was not published until after his death. In the late 19th century, Boyard and Wernicke add to our knowledge of localization of brain function. Wernicke is credited with identifying the localization for the understanding of language in the brain, now known as Wernicke's area. In 1904, Henry Dale was investigating fungus, which led to the theory of the chemical transmission of nerve impulses. Golgi, together with Santiago Ramon y Cajal, received the Nobel Prize in Physiology and Medicine in 1906 for studies of the structure of the nervous system. Cajal was responsible for suggesting that axon scent and dendrites receive nerve impulses. In 1920, Lervy further demonstrated that nerve impulses are a chemical rather than an electrical process. German physiologist and psychiatrist Hans Berger recorded the first human brainwaves in 1924. Expanding on work previously conducted on animals by others, Berger then invented the electroencephalogram, or EEG, an invention described as, quote, one of the most surprising, remarkable, and momentous developments in the history of clinical neurology. Dale and Lervy shared the Nobel Prize in 1936 for describing the neurotransmitter acetylcholine. In the 1950s, Hodgkin and Huxley developed the theory of electrical transmission and the action potential. Psychopharmacology was developed, and there were tons of related experiments with antipsychotics, anti-anxiety medication, etc. Also, this is when the CAT scan came on the scene. CAT scans were developed so that there could be a way to actually x-ray the brain. So I'm going to slow down, stop there, because it begins to get too technical and confusing. The vast scope of modern neurology and neuropsychology is too broad to discuss here. Our knowledge has exploded with the development of brain scanning technology. We've defined and redefined psychological disorders in the DSM, the first of which was in 1952. And we are, of course, now working on another. Psychopharmacology has advanced exponentially, and pharmaceuticals, for better or for worse, are becoming ubiquitous. We have also seen significant advances in standardized neuropsychological testing and neurosurgical techniques. The field of cultural neuroscience now shows that culture profoundly shapes the neurology of self-understanding. We've discovered mirror neurons, which we will learn more about in this class, as well as neuroplasticity. And then there's the concept of neural dark energy, which is showing that our brain is not, in fact, idling when we're not focused on something, but rather it is always active, and in fact slows down when we focus on something. So now I'm really going to stop because I cannot possibly cover all of the discoveries of modern neuroscience. Also, you're probably overwhelmed at this point by the bulk of information and directions that we could take in this course. But as you can see, neuropsychology has a long, long history, and we're learning more every day. For the purposes of this course, we will focus on how this knowledge can benefit you as a clinician. Now, as promised, let's get to our myth busting. So some of you may have indulged in a little too much revelry over the holidays and on New Year's Eve, and you may be lamenting on lost brain cells. The first common myth is that drinking alcohol kills neurons. According to Wang, this became a common belief after a study which looked at the post-mortem brains of heavy drinkers showed that they had smaller brains than non-heavy drinkers. Therefore, people concluded that alcohol kills brain cells. But in fact, research has shown that the actual number of brain cells is not reduced. What is actually happening is that the existing brain cells are only getting smaller in mass. Now, technically speaking, after decades of drinking, a person may develop a disease called Wernicke-Korsakoff syndrome. In this condition, excessive drinking leads to a thiamine deficiency, which then leads to the death of brain cells. There's also some evidence that during pregnancy, drinking of alcohol by the pregnant woman may result in reduced production of neuron development in the fetus. The good news is that giving up drinking can result in the recovery of brain mass, and in fact, small amounts of red wine have been shown to actually benefit the brain. A second myth is that playing classical music to your children, either in utero or in early childhood, will make them smarter. This myth came from a report that was published in Nature, a leading journal of science. The original findings showed that playing classical music to one group of people, which incidentally was college students, not babies, made them somewhat better in one of a group of intelligence tests. It was a transient effect that reportedly went away after 20 minutes. A popular book called The Mozart Effect by Don Campbell in 1997 made claims that supported the myth, but had no actual evidence to back it up. And in fact, the study results were never replicated despite several attempts. So there's actually no evidence to show that playing classical music to your children will make them smarter. Finally, there's this idea that we only use 10% of our brain. This one turns out to be just flat out not true. Wang suggests that this myth came from Dale Carnegie. Dale Carnegie wrote the popular self-help book, How to Win Friends and Influence People, in 1936. Carnegie asserted that William James said that we only use 10% of our brains. He used this misquote to motivate people and essentially sell his books. What James is actually recorded as saying is that we only use a small portion of our brain potential, that circa 1908. Actual facts indicate that, in fact, evidence shows that every part of the brain is necessary for normal functioning. We know this by looking at brain lesion studies. Here's a preview of the assignments for the next 2 weeks. We'll start reading in week 1 both Causalino and Armstrong, complete the terms and concepts assignment, do a little bit of coloring in the coloring book, and of course participate in the discussion forum. For week 2, same thing, a little bit of reading, terms and concepts, a little bit of coloring, and a discussion forum. Finally, here is a list of references that I used to help me create this presentation. So I hope you have a wonderful 2 weeks. I will look forward to our discussion forums. If you have any questions, please contact me. And I hope you enjoyed this first didactic. Take care.